Welcome to 5-6. Today we're going to talk the remainder and factor theorem. A few vocab terms, so make sure to pause the video and get these written down before continuing on. The first one we have is the remainder theorem. That's the value of f of r in a polynomial is equal to the remainder when the polynomial is divided by x minus r. Synthetic substitution, applying the remainder theorem using synthetic division to evaluate a function. A depressed polynomial is the quotient as a result of dividing a polynomial by one of its binomial factors, resulting in a polynomial with a degree 1 less than the original polynomial. And the factor theorem is the binomial x minus r is a factor of the polynomial p of x if and only if p of r is 0. So the two theorems that we're going to be talking about are the remainder theorem and the factor theorem. The remainder theorem, if a polynomial f of x is divided by x minus a, the remainder is the same thing we get if we do f of a. And so they have it written there too. Factor theorem, if a polynomial f of x has a factor x minus a, if and only if f of a equals 0. So we're going to show the remainder theorem first by synthetic substitution. So if f of x is 3x to the fourth minus 2x cubed plus 5x plus 2, we want to find f of 4. And instead of plugging 4 in and solving, what we can do is we can use synthetic subdivision to find it. So f of 4 goes in the top left corner. Then if you remember the coefficients, go here. Now there's no x squared term, so we got to have a 0 to hold its place. Then we're going to do synthetic division. So the 3 gets brought down. The 3 times the 4 gives us 12. We add vertically. We get a 10. Multiply by the 4, again 40. Add. Multiply it over here. Add vertically. Multiply again. And we multiply 165 by 4 and we get 660. Add vertically again. And we get 662. The remainder, that last number, is our solution. So if I'm trying to find f of 4, it is going to be equal to 662. So this is just another way that we can find our answer. So another example, we got h of x is 3x cubed plus 6 or minus 6x squared plus x minus 11. We're going to find h of 3. So if we use synthetic division, again the 3 goes in the top left corner. Our coefficients go right next to that. We don't have any missing exponents, so we don't have any zeros. Again, drop the first number, multiply it with the top left, add vertically, multiply that with the top left, add vertically, multiply with the top left, add vertically. We get 19 as our remainder. So our answer for h of 3 is going to be that remainder of 19. Go ahead and pause the video and do this last one on your own, and then hit play and see how you did. So for synthetic division, you should have put a 0 for x to the fourth and x, so your coefficients should be 4, 0, 2, 1, 0, and negative 1. If you do the synthetic division, you should get a remainder of negative 6, so g of negative 1 is negative 6. So next we're going to see what the factor theorem does for us. So we're going to determine whether x minus 5 is a factor of x cubed minus 7x squared plus 7x plus 15. And then we're going to find the remaining factors. And how we're going to do that, we're going to use synthetic division. So if x minus 5 is our divisor, positive 5 is going to go in that top left corner. Our coefficients, 1, negative 7, 7, and 15. And then we do synthetic division. We drop that first number, multiply it by the top left corner, add vertically, multiply by the top left corner, add vertically, multiply by the top left corner, add vertically, we get a 0. So this 0, that remainder of 0, tells us that it is a factor. Okay, so x minus 5 is a factor. And what we're going to do is we take what's left. Okay, it's 1, negative 2, and negative 3. Remember, if the highest exponent is a 3, we start with 1 less. So this is now what we have left over. Okay, and we can factor this. This is a quadratic. So what I do next, when I factor this, I take first times third, and I get negative 3x squared. After that, I take that negative 3x squared, and I find two numbers that multiply together to get negative 3 and add up to a negative 2. And that's going to be negative 3x and positive 1x. I replace the negative 2x with negative 3x plus 1x. And then I factor by grouping. So I've got 1x squared minus 3x in one factor, a 1x minus 3 in the other. In the first one, I can take out an x, and I'm left with x minus 3. In the second one, I can't take out anything, so I'm going to take out a positive 1. I'm left with x minus 3. So then my two factors here are what's inside of both and what's outside of both. So that is my remaining factors. So my whole thing in factored form is those two that I just found plus the one that I started with. For our next example, we're going to show that x minus 2 is a factor of x cubed minus 7x squared plus 4x plus 12. So again, if our divisor is x minus 2, I'm going to put a positive 2 in the top left corner. I don't have any missing exponents, so my coefficients won't have any zeros, so 1, negative 7, 4, and 12. Drop the first, multiply by the top left, add vertically, multiply by the top left, add vertically, multiply by the top left, add vertically. This 0 here tells me that it is in fact a factor. So I have x minus 2 as part of my factor. Now, to find the other ones, I take what was left over, x squared minus 5x minus 6, and I factor it. So I do first times third, and I get negative 6x squared. Next, I take that product, and I rewrite it as two numbers that add up to a negative 5, so that would be negative 6x and a positive 1x. I replace the negative 5x with the negative 6x plus 1x, and then I factor it by grouping. So I've got x squared minus 6x in one, 1x minus 6 in the other. In the first parentheses, I can factor out an x, leaving x minus 6. In the second one, I don't have anything I can factor out of both, so I'm going to pull out a 1, leaving x minus 6. So my two factors, what's inside the first and what's outside. So then I take those two and I add them to my original one, and I've got my polynomial factored as x minus 2, x minus 6, and x plus 1. Go ahead and pause the video and do this last one on your own, and then hit play and see how you did. So you should have found that it was in fact a factor, and then what was left was x squared minus 2x plus 1. If I factor that, I get x minus 1 times x minus 1. So my factors are x plus 2, x minus 1, and x minus 1, or I can write that as x plus 2 and x minus 1 squared.